Okay, so we're looking at a quiz on probability. We'll try to get through it. We've got 8 pages, so we'll get through it as quick as we can. It's talking about a pack of 52 cards, and just explains the cards. So hopefully you do have done this before, these sort of questions. Okay, so have a go, and when you're ready, come back. Okay, Queen of Diamonds. There's only one Queen of Diamonds, so it's 1 over 52. Part B, an ace. There's 4 aces out of 52, or it's just 1 over 13. Part C, a red king. There are 2 red kings out of 52, which is 1 over 26. D, a red ace. Okay, there's red card, a red card, so there's only 2 colours, so it's a half. E, a jack or queen, well, there's 2 of those for every 13 cards. F, any card except a 2. Well, a 2, there's 4 over 52, so any card except it would be 48 over 52, which is 12/13. G, any card except a jack or a queen, so a jack or a queen is 2 cards over 13, so it's 11 over 13. And H, not a black ace. So a black ace, there are 2 black aces, so there's 50 cards that are not black aces, which is 25 over 26. Okay, next question. Okay, so we've got 6-sided die, blah blah blah. So what you should do is list the outcomes that are possible, and then you can just answer the questions. So they're the numbers that can happen, so have a go. Alright, A, B, C, D, E, F, G, H, and I. Okay, so a 6, there's only 1 of those, that's done. A 3, there's only 1 of those, so that's done. Not a 3, well, a 3 is 1 of them, so not a 3 is 5 of them. A 1 or a 2, well, there's 2 of those, which is 1/3. It's done. A number less than 5, well, they're the numbers less than 5, so it's 2/3. F, an even number or an odd number, well, they're either even or odd, so the answer must be 1. A square number, that's a square, and that's a square, so it's 1/3. Okay, a prime number, that's a prime, that's a prime, that's a prime number, sorry, I thought it was a square number, not a prime number. So a prime number, I'll just go back. So a prime number is 2, 3, and 5. I thought it was a square number, but it's a prime number. So prime numbers 2, 3, and 5. So not a prime number are the others. So it's 3 over 6, which is a half. And a number greater than 1, well, all these numbers, so a number greater than 1, so you don't include 1. So these are numbers greater than 1, so it's 5 over 6. Okay, come across. Okay, we've still got this 6-sided die again, and we're looking for events that have a probability of 6. So we'll just list those outcomes. So 1 over 3 equals 2 over 6. So we're looking for events that happen twice. So you can say yes or no and have a go. Okay, A, B, C, D, E, F. So the first one, more than 6. More than 6 is 2 numbers, so the answer is yes. At least the 4 includes the 4, which means there'd be 3, so the answer is no. Done. C, less than or equal to 3, so that's numbers less than or equal to 3, so that's a no. Tick. D, no more than 2 means those 2 numbers, so it's yes. D's gone. E, at most a 4, well, they're the numbers that are at most a 4, so it's no. And less than 3, these are the numbers less than 3, so it's a yes. Okay, come across. Okay, so we've got a Venn diagram that's us asking numbers, it's not asking for probability. So just try to have a go. Okay, 10, 14, 19, so we've got 26 people, so the fractions will be out of 26. So how many people are in it? 26. So B, part 1, part 2, 3, 4, 5, 6, and 7. Okay, only writing are those 10 people there. So it's 10, 26, which is 5/13. So that's done. Writing in total are those 14 people. 26, so that's 7/13. Part 3, only running is that 5 people there, so it's 5/26, so it's done. Running in total are those 9 people, that's done. Riding and running are just these 4 people in the middle, 4/26. Okay, not run or not ride. So these are the riders and runners. So these people here are neither. So that's 7. Okay, and riding or running. So it's got the word or. So it's riding or running is all those people. So it's 19. Okay, so part C, part 1, part 2. How many people who do not do riding? Well, these are the 14 that ride, so these are the 12 that don't like it. So it's 6/13. And running are those 9 people, so these 17 people don't like it. Okay, so these questions are probability now with Venn diagrams. You must know this as well. So A given B, the formula is A intersection B over B, and B given A is A intersection B over A. So you just divide by the second letter. But I'll show you 2 ways of doing it. So I'll just get these things ready. 2, 3. So we've got to do these questions twice. 4, 5, 6, 7, and 8. 1, 2, 3, 4. Let's go move this. Oh, we'll just start squeeze it in. 4, 5, 6, 7, and 8. So let's have a look at this. Okay. Have a go. Sorry. Have a go. When you're ready, come back. Okay. So these are probabilities. So we've got 5, 6, 13, 15. So we've got 15 people. 15, 34. 15, 34. So this is out of 35 later on. Okay. So A is 6 over 15, which is 2/5. A only are those 5 people, so it's 5 over 15, which is 1/3. Part 3, not B. So these are the B people, so not B are 7 over 15. A and B, so the word and appears, so it has to be in the middle, so it's 1. 5. A or B, so the word or appears, so it's all of them, so it's 13. Part 6, neither A nor B. Well, these are A or B, so these are the neithers. Okay, so we come up to the last ones. So we've got these formulas which we can use, but I'll try to explain it another way. So it says, what's the probability of A given B? So there's the B people, 8. So of those 8 people, how many are doing A? And the answer is 1/8. Using this formula here, we would have had A intersection, which is 1/15, divided by B, which is 8/15, and that equals 1/8. And next one is, given that A's occurred, so given those 6 people have occurred, what's the chance of being B? And the answer is 1/6, which is the same as A intersection B, that's 1/15, divided by A, which is 6/15, and that also equals 1/6. Okay, so that one's done. Let's have a look at the second one. Okay, A is 15, so A is 15 over 35, which is 3/7. Part 2, A only is 12 over 35, which doesn't cancel down. Not B. So these are the B people, so not B is 13 over 35. Part 4, A and B, so the word and appears, so it has to be in the middle, so it's 3. Part 5, A or B, so the word or appears, so it's all of them, so it's 34. Okay, part 6, neither A nor B. So this is A or B, so this is neither, which is 1. And part 7, B's occurred. So of those 22 people, there are 3 A's. So the answer is 3 over 22. And this says that A's occurred. So with A's occurred, how many is B? So it's 3 over 15, which is 1/5. Okay, come across. Okay, so 2 digits are selected without replacement. So without replacement means it's the dependent event. And it says to do a table. You could do a tree, and we don't specify how you do it. So well, I'll do a table. So we've got 1, 2, 3, 4, 1, 2, 3, 4. So this is the table. Okay, now because it says without replacement and there's only those numbers, you can't get double 1, you can't get double 2, you can't get double 3, you can't get double 4. So it's 1 and 2, 1 and 3, 1 and 4, 2, 1, 2, 3, 2, 4, 3, 1, 3, 2, 3, 4, 4, 1, 4, 2, 4, 3. So there's the thing. So we've got 12 things that can happen, okay, because these ones can't happen. So part B, what's the chance of being a 1 and a 2? Well, there's only one of those out of 12. 4 and a 3 is also 1 over 12. Part C, both numbers will be at least a 3. So that's at least a 3, and those numbers are at least a 3. Okay, this one is 1, 3, but the other one's not. This one's bigger, but that one's not. So the answer is there's only 2 answers. So that's 1 over 6. So that's part 1, part 2, part 3, part 4. Okay, so we've done that one. The outcome will contain a 1 or a 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 5 over 6. The outcome will contain a 1 and a 4. Well, there's only that one there and that one there. So the answer is 2, which is 1 over 6. The outcome will not contain a 3. So we can't have anything there, and we can't have anything there. So we've got 1, 2, 3, 4, 5. I can't have those, sorry. Can't have those. So we've got 1, 2, 3, 4, 5, 6. Which is a half. Okay, let's have a look. We've got a couple pages to go. Okay, so fill in the tree diagram and assign probabilities, and we're tossing a fair coin. Okay, so the branches have started for you. You've got to know how to do a tree, but we've done this for you in this particular case. Okay, so have a go. So we're tossing it 3 times. So that's the first toss. This is the second toss, and here is the third toss. Okay, so we've got head, tail, head, tail, head, tail, head, tail, head, tail, head, tail, head, tail. So we've got head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, 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 head, tail, tail, tail. Okay, and it says assign probability. So each of these is equally likely. There's 8 outcomes, which is the same as saying 2 for the first times 2 for the second times 2 equals 8. There's 8 outcomes. They're equally likely, so each of them is 1/8, etc. And that adds up to 1. So each of them is going to be 1/8. Okay, come across. Okay, last page. Okay, so we've got without replacement. Okay, so the probabilities change. Got to complete this tree diagram and obviously put the probabilities in, and then we can answer the questions. So we've got 2 reds, 1 blue, 1 yellow. So if you take a red, there's still a red, and we haven't touched the blues and yellows. So these are your two reds, red, blue, yellow. We take a blue, there's a red, or a yellow. We take a yellow, there's a red, or a blue. So red, blue, red, yellow, red, blue, red, yellow, BR, B yellow, R, yellow B. So we've got 3, 6, 9, 12. So each of them is going to be 1/12 likely. Okay. So we've done that. Fill in that. Find the probability of obtaining a red sock and a blue sock. A red sock and a blue. A red sock and a blue. A blue sock and a red. A blue sock and a red. And so the first answer is 4/12, which is the third. Part 2, 2 red socks. Okay, there's 2 red socks there, there's 2 red socks there, so it's 2/12, which is 1/6. Part 3, any pair of socks of the same colours. So same colour, same colour. Oh, there's no same colours there. So you can only get those two answers. Let's think, any pair of socks of the same colour. Well, we've only got 2, you can only get those 2, I think. I think that's right. You can't get a pair of yellow socks because you've only got 1 yellow sock. Okay, and part 4, any pair of socks of different colours. Well, we've just got, that's the only chance of getting the same colour, so different colours must be 5/6. Okay, that's it. Thanks, bye.